Hello students, I am Abhinav Puranik. I am taking gravitation in minutes. So gravitation starts from Kepler's law. So there are three laws. First law is law of orbit. So what is that? The sun's position is at the focus of the ellipse. This is not exactly circular orbit. The circle is in the form of ellipse, means it has one major axis and one minor axis, and sun's position is at the one of the foci. What about the other focus? That other focus is empty for our solar system, and the planet is revolving around this sun and like this around the orbit. Therefore there is maximum distance of the planet from the sun. So this is r max, and this is minimum distance from the sun. This is r min. So when we take that ratio of r max to r min, so the ratio is r max to r min, that ratio is 1 plus e upon 1 minus e. This is additional extra formula. So we know what is the basic law, but formula is important. R max to r min, maximum distance to minimum distance is 1 plus e upon 1 minus e. What is that e? E is the eccentricity of ellipse. So eccentricity is 0 only when it is a circle. So for circle, eccentricity is 0. If there is eccentricity, therefore that is a circle, and we have r max and r min values. So this is apogee and perigee. So perigee is this position for r min, and apogee is the maximum distance from the sun. So therefore r max to r min is apogee distance to perigee distance is 1 plus e upon 1 minus e. So we know all about this eccentricity because we know maths, and in the maths we have that eccentricity in the ellipse, equation of ellipse. This is all about first law. Then there is second law. Second law is much important because we know the equation that every planet sweeps equal area in equal interval of time. So take this one time interval. For example, for Earth there is 1 month, and within that 1 month we have so much distance, and the base is greater and height is smaller, and in the same 1 month away from the sun we have base smaller and height is greater. Therefore what happens? This area A1 and this area A2 are exactly equal because the base is greater, height is smaller. Here height is greater and base is smaller. What about area? Area is half base into height. Therefore we have that the total angular momentum of the planet remains same. In the same area, means A1 is equal to A2, we have angular momentum as a constant. So what is equation for second law? Angular momentum is constant. Angular momentum L is P into R. So distance into linear momentum is angular momentum R cross P, or PR is angular momentum constant. If the mass of planet is constant, that means we have m into v into r is equal to constant. mvr is constant. So mass into velocity is linear momentum, therefore m into v into r is constant. What is r? R is the distance. So when our distance is smaller, then velocity is greater. When the distance is greater, velocity is smaller. Because mass is constant, therefore v is inversely proportional to r. In all numericals we have to use this. When the distance is smaller, velocity is greater, and when distance is greater, velocity is smaller. It is inversely proportional. This is all about second law. The statement is, we all know that equal area in equal interval of time. This is all about second law. Then take third law. So in the third law, there is time of interval. So the distance, we know what is the distance. The average distance we can measure minima and maxima distance, major axis and minor axis. The center of ellipse gives the average distance. That means the distance from this part is known as semi-major axis, is indicated by A, and the square of time period is directly proportional to A cube. What is that A? A is not radius, A is not normal distance, but it is A minimum distance, means this is major axis, and take it half means it is semi-major axis. So t square is directly proportional to a cube, is that basic law and the equation of third law. Maximum numericals will be from this equation. Let's take that the normal time period of Earth is like 1 year, and when we take that distance doubled, means the second distance is double than first distance. So in general numerical, what they ask, when the distance is doubled than the normal distance, means a2 is equal to 2 times a1, find the new time period of Earth. Means we have to find what is the new time period in the year, or we can multiply it by 365, we can get in days. So what is basic relation? T square is directly proportional to a cube. So we will have T2 upon T1, its square is equal to A2 upon A1, its cube. So what is A2? A2 is 2 times A1. So place that 2 times A1 upon A1, its cube. So A1 gets cancelled out. So 2 cube is 8, and then we have to finally take square root of that 8, which is 2 root 2. So we know T1 is 1, therefore we get T2 is equal to 2 root 2 times year, or into 365 days. So T2 is equal to 2 root 2 year. So our final answer or the new time period is 2 root 2 years. Is it clear? Then take the next example. If what happens when the time becomes double? So when the time becomes double, again use the same relation. Time becomes double. What is the new distance? So 2 times T1. Find A2 value. So we have to find what is the second distance or the new distance, and normal distance is taken as 1 AU distance. What is AU? AU is the astronomical unit distance. It is the current distance between Sun and Earth. So A1 is taken as 1 AU. What is A2 in terms of AU? We have to use again the same relation. T2 upon T1 is equal to A2 upon A1, and see what happens. We have to take cube and directly square root. So A2 upon A1 raised to 3 by 2 is our final formula, or when we shift this power, we will get T2 upon T1 raised to 2 by 3, which is A2 by A1. So both formula we have to remember for any different numerical. Then T2 upon T1 raised to 2 by 3. So T2 is 2 times T1. So we will have 2 times T1 upon T1 raised to 2 by 3 is equal to A2 by A1. T1 gets cancelled, so time period gets cancelled, and we have second distance as 2 raised to 2 by 3 of A1. So A1 is 1 AU, 2 raised to 2 is 4, cube root of 4 is our final distance in AU. So we will get A2 is equal to cube root of 4 AU. Is it clear? So this is all about Kepler's law. There are 3 laws, 3 equations, and our Kepler's law is completed. Then the next part is basic main law, is Newton's law of gravitation. So Newton's law, what is Newton's law? This is very famous law, and we are studying this law from our basic schools. So that force of attraction between two masses, any two masses or masses of that object, is directly proportional to product of masses and inversely proportional to the square of distance between them. And what about that distance? That r distance is not normal distance. If there are different objects like sun and earth and moon, then all distances are to be taken from their center of mass. So this is not surface to surface distance. This distance is always from center of mass. So that r distance is the distance between m1 and m2 from center of mass. Therefore, that proportionality constant is capital G m1 m2 upon r square. G is universal gravitational constant. This is all we know, and the new quantity is the force. Force in vector form. This is normal force in scalar form, and f bar is the new equation in vector form. So remember that vector form G m1 m2 upon r cube when there is a vector r bar. R bar is the distance taken from first to second or second to first. Depending on that distance, we can change that f also. If the distance is taken from first to second, means this is the distance measured from first to second. Therefore, that force is acting on second due to first. So this is sign convention when the distance is measured from first to second, because first equation means the first mass is exerting any force on second object. Therefore, this is the force on the second due to first. This is main part. Symbol is reversed. Is it clear? Then the opposite way, when it is 1, 2, force 1, 2. What is force 1, 2? It is the force acting on first due to second object is the capital G m1 m2 upon r cube, and this is r from second to first r bar. Is it clear? This is a very important step, and if this is r cube, then we have to multiply with normal vector. If we have to place that G m1 m2 upon r square, when r square is compulsory, then we have to multiply it by only unit vector. So unit vector from 1 to 2. If we have to place that same m1 m2 upon r cube or r square, then we have to place this r cap from 2 to 1. So this is all about forces. So this is Newton's law of gravitation. There are some numericals on it also. For example, if one object is placed like this is first object of mass 1 kg, and the second object m2 is placed as 2 kg, then we have to find what is the force of attraction. Force of attraction are always towards each other, and there will be some point in between them when the distance is also taken, like 10 meter is the distance between two objects, and we have to find where the point is having same neutral gravitational force. Means at this point total force from m1 and total force from m2 will cancel each other. So take that formula, F is equal to G m1 m2 upon r square as basic formula. Now the force at this point is F1 force. Second point, F2 force on the unit mass object, means that mass is 1 kg object. On that mass we can find this force as equal and opposite. How it is possible? Let's calculate. That F1 is equal to G m1 m2 upon r square. The distance is 10 meter. Take this distance, one distance as x. So the remaining distance becomes 10 minus x. So we have to put that distance for this 1 kg mass as F1 force. So F1 is equal to capital G. First mass is taken as 1 kg. The unit mass is taken as again 1 kg, and the distance is as x square. For the second force, F2 is equal to, what happens? Capital G is same, m1. Now the first mass is 1 kg. m2 is taken as 2 kg upon the distance. The distance between these two objects is now 10 minus x, and its square. If the force is in equilibrium, means F1 is equal to F2, forces are balancing, then we have to balance both equations. So G 1 into 1 upon x square is equal to G 1 into 2 upon 10 minus x its square. So how to calculate? G and 1 gets cancelled, G and 1 gets cancelled, and then there is 2 upon 10 minus x square upon x square. Then generally what we do? The trick of calculation is here. We don't have to take a minus b bracket square. We have to take square root on both sides. So this is main important trick. So we have to take square root on both sides. So 1 upon x square becomes 1 by x. And to the right side, 2 upon 10 minus x becomes root 2 upon 10 minus x. So it is very easy to calculate. Then cross multiply. So 10 minus x is equal to root 2 times x. Then we will get root 2x plus x is equal to 10. Take x common. So x 1 plus root 2 is equal to 10. So we will get x is equal to 10 by 1 plus root 2. So this is our final distance. So we have to calculate that distance x, and we will get that distance x is equal to 10 upon 1 plus root 2. If we know the value of root 2, we can again approximate that equation. So root 2 is approximately 1.4. So 1.4 plus 1 is approximately 2.4. So 10 upon 2.4 is about, let's take that 2.4 is as 2.5, and we will get approximately 4. So x is about 4 meter from the first mass, because x is the distance from first mass, and we have calculated that distance is 4 meter from first mass, where any point object like 1 kg, because 1 kg gets cancelled from both sides, any mass 1 kg, 2 kg or any kg mass is placed is experiencing the same equal and opposite force. Means that point is in equilibrium. So gravitational equilibrium we are getting at x is equal to 4 meter for this numerical. So this numerical is very important numerical for balancing part. Then the next part and the main important major numerical part is acceleration due to gravity. Why there is acceleration due to gravity? Because when we place any object on the surface of earth, this object is placed on the surface of earth. What is the distance of this object from the surface of earth? Is 0. But what is the distance of this object from the earth? Remember that distance is always measured from the center of earth. Therefore, that distance is not a 0. When we place that mass on the surface of earth, means we have to calculate that distance from the center of earth. When we place that mass above the surface of earth, means we have to add that height to the radius of earth. So r is the radius and h is the height. Therefore, total distance between earth and the mass is now r is equal to capital R plus h. R is used as, capital R is used as radius of earth, and small r is used as total distance between center of earth to the mass or the center of second object. So this is very important part. R is equal to R plus h, and we have to calculate what is the acceleration acting on this mass when it is placed on the surface of earth. So what is that G? G is generated because of the weight. What is weight? Weight is basically force. Force generated by the gravitation is mg, weight, which is balanced by our normal formula is G capital M small m upon r square. What is r? We know that this r is for the surface of earth. When the distance of mass and the earth is 0, means capital R is the final distance between two objects. So capital R is generated due to object is placed on surface of earth. Small m is the mass of that object and capital M is the mass of earth. So that capital G into capital M is the main product. Small m gets cancelled out and G is equal to capital G M upon R square. This is main formula for acceleration due to gravity. So G is equal to Gm upon R square. What is R? We know that R value is about 6,400 kilometer, or it is in 6.4 10 raised to 6 meter. Capital M is the mass of earth, is about 6 into 10 raised to 24 kg, and we know the value of G is 6.67 into 10 raised to minus 11, and the unit is, we can measure that unit from the basic formula, F is equal to G m1 m2 upon R square. So this is G. Unit of G is calculated by Newton into meter square. So this is Newton into meter square upon m1 m2 has masses, means kg into kg becomes kg square. So Newton meter square upon kg square is the unit of capital G. Remember, for earth, that capital G into m, the product, what we get? 6.67 into 10 raised to minus 11, then into 6 into 10 raised to 24. So 6.67 into 6 is approximately 40. So we can take that as 40. 10 raised to minus 11 and 24 becomes 10 raised to 13, and we will get the final result as 4 into 10 raised to 14. So 4 into 10 raised to 14 we have to place when m is the mass of earth. Majority times we have to calculate this only for earth. Therefore G into m we don't have to put and then calculate. We can put that only final factor 4 into 10 raised to 14. So we have to put 4 into 10 raised to 14. And if we know capital R 6400 kilometer or 6.4 into 10 raised to 6 meter, then finally we are getting that 9.8 meter per second square formula. We can approximate it as 10. But remember, this formula is not constant and the value is not constant. This value is the average value of acceleration due to gravity on the surface of Earth. That means there is variation of small g from surface of Earth to the height, from surface of Earth to the depth towards the center, and from the surface of Earth from equator to pole. So when we move from equator to pole, this value is going to change. Then we will see that variation of g. So variation of g, small g, is first variation due to height. So when we move that object from the surface of Earth to the height, certain height above the surface of Earth, what happens to that acceleration due to gravity? So what is our basic formula? G is equal to capital G m upon r square. At certain height, what is changing? Capital G is a constant, so it is not changing. Capital M is the mass of Earth, it is also not changing, but small r will be there instead of capital R. What is small r? Is the distance from the center to the surface, and h. So capital R plus h is that small r. We can put that capital R plus h here with bracket square and then take the ratio. So gh upon g, what we are getting? That gm and gm gets cancelled. Gh is inversely proportional to r plus h bracket square, and g is also inversely proportional to r square. So we are getting gh upon g is equal to r square upon r plus h square, or we can take in the common bracket as like this. So this is our basic formula, and this is a generalized formula for gh upon g. So g can take to the right side and we are getting that value of gh at the height. R upon r plus h bracket square into g is the value of gh. This is used for any relation, therefore it is called exact formula. This is exact formula. Everywhere we have to use this formula when the height is very small, when the height is very large. For any height is known or unknown, we have to use this formula as the exact formula. But there is another formula like approximate formula. What is approximation here? So let's calculate that approximation also. So gh upon g is equal to what we are taking, that height r plus h, and that numerator value of r goes to denominator's denominator with the bracket square term. 1 square is again 1. And then we have to calculate this part as 1 plus h upon r bracket square. This square part goes to numerator as 1 plus h upon r raised to minus 2. And then we have to use that approximation part again. What is approximation here? That the first term is 1, the second term is negligible term when the height is very small. When we have to take this height is negligible compared to the radius of Earth. What is radius of Earth? Is 6,400 kilometer, and when the height is like within 1 kilometer, 2 kilometer, or 10% of radius of Earth means 640 kilometer. Up to 640, this factor is again negligible. 10% means it is about 0.1. So 1 plus 0.1 raised to minus 2 is negligible. So we have to use that binomial approximation. First term should be 1, second term should be negligible, bracket should have a power, therefore that power should be multiplied to the second term. So that approximate formula is 1 minus 2 h upon r. So this is approximation for acceleration due to gravity. Again multiply this g and we are getting that approximate formula for g into 1 minus 2h upon r as gh value. Remember, this formula is approximate formula. Approximation means when the height is very small, within the 10% of radius of earth, then we have to calculate this formula, or when the height is unknown, when height is very large, then we have to use that first formula as exact formula. So we have exact formula and approximate formula, and depending on the condition which is given in the numerical, we have to select this exact formula or approximate formula. So conditions are clear. Then we will move to the second part, which is variation of g with depth. So the second part is for depth. So depth formula is basically normal condition is approximate formula. We have to consider so many things to calculate this depth part. So many things means first part is that earth is complete sphere. So earth is a sphere and a perfect sphere. Earth is spherical, we know, but it is not a perfect sphere. So it is not perfectly spherical. And second part, the density of earth is uniform. Density of earth is not uniform from center to the surface. Density is changing. So we have to consider all these 2 points, means earth is perfectly sphere and density of surface density is constant. For earth this is always constant, and we are considering this part as approximation. So therefore we have to calculate approximate relation. So what is that depth part? We are moving to the depth on the surface to the depth. So to the depth, when we consider that depth part as a spherical part, when the main earth is taken as capital M and the inner earth is taken as M dash, because mass is subtracted. Only smaller part is to be taken, therefore total mass is capital M, mass of earth, and M dash is the small part at the depth. At the depth means this is D, and the remaining radius of the inner side part is capital R minus D. So we have to subtract that part. Therefore total mass should be subtracted. What is the main formula for G? Is capital G M upon R square, and this formula is only for the surface formula. At the depth, this formula changes as GD is equal to G M dash upon R minus D bracket square. So this formula changes. And what about capital G? We can take again the ratio similar to when we have taken in height part. Same way we are taking this GD upon G part. What is cancelling out? That capital G is cancelled out, and we are getting that R minus D square part. And here we are getting R square part, but remember M is not cancelling out, M is there. So this is M dash and this is M part. So what about this M? Then take that approximation, second approximation. Density is constant. Density and mass related as density is equal to mass upon volume, and when there is volume of sphere, again the first approximation is a perfect sphere. That means volume should be mass upon 4 by 3 pi r cube. This is the density. So mass is equal to 4 by 3 pi r cube into density. For the second mass, 4 by 3 pi, there is no r but r by d cube, and the density is constant. So we have to put this M dash and M in this formula. See what happens, r square and then M dash is 4 by 3 pi r minus d cube into density divided by again r minus d, its square. M is now 4 by 3 pi r cube into density. So 4 by 3 into pi gets cancelled, densities also gets cancelled. So r cube and r square. So we are getting only r here, r minus d square, and this is r minus d cube. So 1 r minus d is present in the numerator and 1 r is present at the denominator. So r upon r becomes 1 and d upon r will be there. So we are getting the final formula as gd is equal to 1 minus d upon r into g. So this is approximate formula. This is always approximate formula because we are using this approximation, two approximations to calculate gd value. So 1 minus d upon r into g is that gd value. Is it clear? Then the third part or the third variation is the variation from equator to pole, means it is with the latitude. So from the surface we are moving from equator to pole. So this is equator. Equator is a great circle. So we know this radius is capital R. We are moving on the 0 degree. 0 degree is the latitude of equator, and to the pole there is no radius because it is rotating with the axis. So that point is rotating with the axis and axis is passing actually through the pole. Therefore there is no radius, or the radius at this point is 0, and that radius is not moving, means the angle is 90 degree. So at equator latitude is 0, at the pole latitude is 90, same to the opposite side, means to the south pole also the latitude is 90, and we are getting the final formula of that g latitude is equal to g minus r omega square cos square phi. So we don't have to take that derivation here because this is exact final formula, g minus r omega square cos square phi. What is omega? So we should know all different parameters from this formula. R we know, this is the radius of earth. Omega is the angular velocity. So what is angular velocity? Angular velocity has a main formula as 2 pi by capital T. What is capital T? Capital T is the time period of earth. Means what is the time required to rotate one circle around the axis is obviously is 24 hours, and we have to convert that 24 hours into second also. So this is actually 2 pi by 24 hours into 60 into 60. So it is converted into second. So 2 pi by 24 hours or 2 pi by 24 into 60 into 60 in that second is radian per second is the unit of angular velocity, and phi is our latitude. So see what happens to this latitude when we take that phi is equal to 0. Phi is equal to 0 means the point is at the equator. So point is at the equator. So at equator we have to calculate that g value and then use this formula, main formula. So g is equal to g at latitude or at equator is equal to g minus r omega square into cos square phi. Cos square phi is cos square 0. What is cos 0? Cos 0 value is 1. Therefore 1 square is again 1, and we are getting the smallest of the acceleration due to gravity is g minus r omega square. And the final formula is for pole. At the pole phi is equal to 90 degree. Therefore g at L is equal to g minus r omega square and then cos 90. What is cos square 90? Cos 90 is 0, so cos square 90 is again 0, and the second term gets cancelled out and we are getting the small value g. This means the acceleration due to gravity is the least value at the equator and it has maximum value on the poles. So g is maximum at pole, which is small g, and on the equator that value is g minus something, means minus that r omega square is the final value. So on the pole we are getting this value. Okay, so we have completed the main theoretical part here.